Hello students, what is going on? My Abdullah Momin from KMS English Medium High School and Junior College, and today we are going to start a new chapter, that is chapter number 3 from your textbook, that is motion in a plane, from class 11th physics. So first of all, we are going to study about the very basic definition of motion. Okay, what is motion? So motion is a change of position of object. If at time t1 object is at point A and it changes its position to point B, then we will say that motion occurs. So we have come across the motion of a toy car when pushed along some particular direction, the motion of a cricket ball hit by a batsman for a six, and the motion of an aeroplane from one place to another. So these are the some types of motion which we study or which we see in our daily life. The motion of an object can be divided into three categories. Number one is motion along a straight line. If an object is moving along a straight line, then it is called as rectilinear motion. Motion in two dimension means motion in a plane. Suppose a ball is hit by a batsman for a six, so it is going to cover some distance, and the object is changing its position along x-axis also and along y-axis also. So this is plane when the motion occurs along two axes. So this is two dimensional and it is called as motion in a plane. Next is motion in three dimension, means motion in a space. Next, what is rectilinear motion? So in rectilinear motion, the force acting on the object and the velocity of the object both along one and the same line. So rectilinear motion means motion in a plane. Suppose an object is moving in forward direction while we are applying the force. So direction of velocity and direction of force both are in the same line, in the same direction. So this is called as motion, rectilinear motion. And the distances are measured along the line only, and we can indicate distance along the positive and negative axis as being positive and negative respectively. So if this object is moving in opposite direction, we will consider this as negative, and if it is moving in forward direction, positive direction, we will consider is at positive. The study of motion of object in a plane or in a space becomes much easier, and the corresponding equation becomes more elegant if we use vector quantity. So in this chapter we are going to use some vector quantities. So first we will recall the some basic facts about rectilinear motion. We will use the vector notation for this study as it will be useful later when we study the motion in two dimensions. So we will then study the motion in two dimension, which is nothing but motion in a plane will be restricted to projectile motion only. Circular motion, the motion of an object around a circular path will be introduced here, and we will be studied it in detail in the next standard. So the very first thing which we are going to study is displacement. So what is displacement? The displacement of an object between time t1 and t2 is the difference between the position vectors of the object at the two instances. Thus the displacement is given by, suppose initially at time t1 the object is situated at x1, at time t2 the object is situated at x2. So how much displacement has been occurred? So final minus initial. So displacement is denoted by delta x or s vector quantity. So we will write x2 minus x1, that is the displacement of the object. Suppose initially the particle is at 60 and this point is at 80. So final means 80 minus 60, 20. So the displacement is 20. And in which direction? We will write positive direction. And if it is moving towards negative direction, and suppose this point is 40, it is moved from 60 to 40. So final position is 40. So x2 means 40 minus 60, we will get minus 20. So it moves in negative direction up to 20 units. So this is the displacement. It can be positive, negative, or zero. Now path length. This is the actual distance traveled by the object during its motion. It is a scalar quantity and its dimension is also that of length. If an object travels along x-axis from x is equal to 2 meter to 5 meter, suppose the particle is initially x is equal to 2 meter and it moves to x is equal to 5 meter, then the actual distance is covered by 3 meters. So we will say that the path length is 3 meter and it is a scalar quantity. Next, average velocity. So this is defined as the displacement of an object during the time interval over which average velocity is being calculated, divided by that time interval. As displacement is a vector quantity, the velocity is also a vector quantity and its dimension is L1 M0 T1 minus 1. So we have studied this in our chapter number 1, that is units and measurement. Now suppose if a position vector of an object are x1 and x2. Suppose particle initially situated at x1 at time t1 and its position changes, means is moved to x2 and the position x2 is at time t2. Then the average velocity can be written as x2 minus x1 divided by t2 minus t1, that is average velocity. Next, average speed. This is defined as the total path length traveled during the time interval over which average speed is being calculated divided by the time interval. Average speed is equal to path length upon time interval. Suppose object moved from 40 to 60 and then it comes back to 20. So total path length 20 plus 20 plus 20. Total path length is 60 and if it takes 6 seconds, so we will say that speed is 10. So path length is nothing but total distance covered, total path covered divided by time. And it is a scalar quantity and its dimension is same as that of velocity. Next is instantaneous velocity. Instantaneous velocity of an object is the velocity at a given instant of time. It is defined as the limiting value of average velocity of object over a small time interval when time interval goes to 0. So limit delta t tends to 0, delta x upon delta, that is displacement upon time. It can also be written as dx upon dt, and this is your derivative which we are going to study in second chapter, that is mathematical method. So instantaneous velocity is delta dx upon dt, or limit delta t tends to 0, delta x upon delta t. Next is instantaneous speed. So instantaneous speed is the speed of an object at a given instant of time t. It is the limiting value of the average speed of the object taken over a small time interval delta t. Time interval goes to 0. In such a limiting, the path length will be equal to the magnitude of displacement. And so the instantaneous speed will always be equal to the magnitude of instantaneous velocity. So the magnitude of instantaneous velocity is nothing but instantaneous speed. Now we are going to solve this equation. Example, that is example number 3.1 from your textbook. A person walks from point P to point Q along a straight road in 10 minutes. Suppose this is point P, this is point Q, and this distance is covered in 10 minutes. Then turn back and return to point R, which is midway between point P and Q, after further 4 minutes. Then it again come back to the point which is R, and R is the midway point. Initially it moves from P to Q in 10 minutes, then it comes back from Q to R in 4 minutes. If PQ is 1 kilometer, find the average speed and velocity of the person going from P to R. So P to Q, this distance is 1 kilometer. So the path length traveled by the person is 1.5. So when it moved from P to Q, it covered 1 kilometer, and then after it returned to the midpoint, that is our, the total distance covered is 1.5 kilometer. And while the displacement is the distance between R and P. This is the displacement. Final position minus initial position. Final position, suppose this is 0, this is 5, this is 10. So final minus initial, 5 minus 0. So it is 5 or 0.5. 0.5. The time taken for this motion is 14. So the average speed is total path length covered. That means 1.5 divided by total time 14. So this will be your 0.107 kilometer per minute or kilometer per hour. And the magnitude of average velocity is 0.5. So this is the average velocity. So average velocity can be written as in kilometer per hour in kilometer per minute. So thank you, student. Thank you very much. I will catch you next time.